All right, so we are going to talk today about parallel and perpendicular lines. So what is a parallel line? Or I guess you can't have one parallel line. What are two parallel lines what, Victoria?
Lines that align with each other.
What do you mean they align with each other? And I see what you're doing, but I need it in words. So what are you doing here? They hover over each other, and do they what? They never ever touch. So parallel lines are two lines that are never going to intersect each other, all right? They never intersect each other. So if parallel lines are on a coordinate plane, like this blue line and this red line right here, let's take a look at the blue line. I'm going to write it a little bit bigger. The equation of this line is y equals 1/2 x plus 5. What form is this in? Y equals mx plus b. Does anybody remember what that's called? Is that point slope or slope intercept? Slope intercept. So this is slope intercept form. All right? If it's in slope intercept, that means which one of these is our slope? 1/2. So this right here is our slope. And this right here is our y-intercept, right? So it's where it crosses the y-axis, which, take a look at this. Obviously, these are counting by 2's, right? It goes 2, 4, 6, 8, because that's got an 8 up there. So that means that's crossing at 5. Now look at this red line. The red line is y equals 1/2 x plus 1. So that means our slope is 1/2, and our 1 is our y-intercept. It crosses the y-axis at 5. The blue one. Because this is counting by 2's. All right? So then the red one crosses the y-axis at 1, and the slope is 1/2. What do you notice about the blue and red lines? They're parallel. They don't touch each other. Do you notice anything about the equations of the blue and red lines? What do you notice about the equations of the blue and red lines? David? The slope is the same. So do you think there's anything that you can conclude about parallel lines? The slope is always the same. The slope of parallel lines is always the same. What about the y-intercepts? It has to be different. Why?
Because they don't touch each other.
Because they're not, if they were, so Brian, if the slope were the same and the y-intercept were the same, what would they do? They'd be on top of each other. We call those coincident lines. You don't need to know that right now, but in geometry we'll talk about it again. So coincident lines are lines that are just on top of each other, okay? In this case, to be parallel, they have to have the same slope, but different y-intercepts. Why do you think the slope has to be the same? Gabe, what do you think? If they weren't the same, they wouldn't be parallel, because think about the slopes of lines. Remember when we first started talking about slope and we said something that was really shallow is like a handicap ramp, right? So if I have a handicap ramp like this and it's kind of a shallow slope, and then I have another line and it's like a mountain and it's a really steep slope, these two lines are going to ultimately have to touch each other because at some point they're either coming closer together or moving farther apart. So if the slopes of a line are the same and the y-intercepts are different, then they're parallel lines. What do you notice about these two lines, this red and this blue, and the second one? Are these two parallel lines? Yes. What's the slope of this line, this blue one? What's the slope of this blue one? Think about slope, dude. Undefined. It's undefined because it's what kind of line? Straight up and down, starts with a V? Vertical. And this red line is also vertical. What do you notice about the equations of those lines? They don't have a Y. They have no Y. Those are just X equals. That means it's a vertical line. All right? That means it's a vertical line. All vertical lines are parallel. Because if a line is straight up and down and another line is straight up and down, then they have to be parallel.
What would you call it?
If they were right on top of each other?
They will have the same X?
They have the same X. Then they'd be coincident lines again. All right? So if an X equals line goes vertical, what does a Y equals line do? Horizontal. So let's say we have this right here. This green line would be Y equals -2. Or sorry, is this going by ones or twos? This is going by ones. So it'll be Y equals -1. And then this black line is Y equals 3.
When does it go horizontal?
When it's a y equals. So when it's a y equals, it's a horizontal line. So this black line and this green line are horizontal lines. Are they also parallel?
Yes.
Yes, they're also parallel. What's the slope of a horizontal line?
0.
0. So any horizontal line is going to be parallel to any other horizontal line, because if it goes straight horizontal, then any other horizontal line will never touch it.
Oh, what? There's no x on that one. So.
No, that's a y.
Is there any way that they could be constant?
Yes, if it were y equals 3 and y equals 3. So if they were exactly the same. Because that tells you where it crosses the y-axis. So like right here is y equals 3, so that's why it's y equals 3.
It only has to be the same and be parallel whenever it has an x.
When it's either just x's, just y's, or when the slope is the same. All right? So those are your 3 instances of when it's parallel. Again, parallel lines, same slope. All right? Parallel lines have the same slope. Okay, are these lines parallel?
No. Yeah. Yes.
Yes? Micah, what's the slope of this first one? And what's the slope of the second one? Okay, so they have the same slope. Gabe?
So is this horizontal?
No.
That's a straight. That's like
It's only horizontal and vertical if it's just like y equals 3 or x equals 2. This would be a vertical line. This would be a horizontal line. All right? If there's no x in that, then it makes it a horizontal line. If there's no y at all, then it makes it a vertical line. If it has both, then it's neither. Then it's not vertical or horizontal. All right? So what's the y-intercept of this first one? 3. What's the y-intercept of the second one? -2. So are they parallel? Yes, because they have the same slope, but different y-intercepts. So these are parallel lines, all right? And if I were to graph this one, how could I do that? Where would I start?
4, 3. No. 3.
At positive 3 what? On the,
Positive 3, 1.
on the y, it's the y-intercept, so I started at positive 3 on the y-axis, because it's y-intercept, all right? And then from there, what do I do?
Go up 4 and into the
1, 2, 3, 4, 1, 2, 3, and there's my line.
So you would go up 4?
Up 4, right 3, because they're both positive. All right? Where would this red one start? -2 on the y-axis. It's always the y-intercept. And then I would go
4,
up 4,
right 3.
1, 2, 3, right 3. All right? And these are parallel lines.
Not again.
One thing I want to say is don't forget to count the origin. All right? So when you're going up 4, a lot of people were skipping 1 and going 1, 2. This is a spot right here. 3, 4. 1, 2, 3. Okay? All right, so parallel lines have the same slope, different y-intercepts. So take a look at these 4. I don't even need this coordinate plane. I'm going to move it because that's just giving us more work to do. I want to figure out if these 4, which ones are parallel. So this is written really small, so I'm going to write them a little bit bigger. Our first one is y equals 3x plus 2. Our second one is y equals -1/2 x plus 4. Our third one, I'm going to label this 1, 2. Our third one is x plus 2y equals -4. And the fourth one is y minus 5 equals 3x minus 1. Okay, Gabe, go.
Do we write on the coordinate plane because you're not going to use it?
Yeah, you can write on it. I'm not going to use it. All right, so I need to figure out which ones are parallel, which means I need to look at their whats? At their slopes. I need to figure out if their slopes are the same. And the y-intercepts have to be different. Okay, so 1 and 2 are already in what format? Y equals mx plus b. So do I have to change those at all to figure out the slope? So what's the slope of number 1? 3 is the slope. And what's the y-intercept? 2? Okay, so there's our slope and there's our y-intercept. What's the slope of number 2? All right, and what's the y-intercept?
4.
Okay, Are these parallel to each other? No, those are not parallel to each other. So 1 and 2 are not. What's wrong with 3 and 4? Nothing's wrong with them, but they're not y by themselves, right? So if they're not y by themselves, can I compare them yet? No, I've got to get y by itself. So let's do that with number 3 first. If I want to get y alone, what do I need to get rid of? X and 2. What am I going to get rid of first, the x or the 2? The x. How do I get rid of a positive x? Subtract x minus x. So then what do I have left over here? No, it's not. I can't combine those because one has an x and one doesn't. Micah. Negative x minus 4. Why do I want to write that instead of negative 4 minus x? Yorath? Because I want it in the format y equals mx plus b. So is it wrong to say negative 4 minus x? No. A lot of you guys were saying that. That's not wrong. We just want it in this mx plus b format, so we put the x first. What number is in front of here? 1. There's an imaginary 1. I'm going to put it. Now how do I get rid of the 2? Divide by 2. What do I divide by 2 over here? Everything. So divided by 2, divided by 2. So then what happens? I've got y by itself. What's this become? Negative 1 over 2x. And then what's 4 divided by 2? Good. All right. So there's my slope-intercept form. So what's the slope? So is that parallel to either of the other ones? Which one? Number 2. So 2 and 3 are parallel. All right. So 2 and 3 are parallel. These go with each other. Gabe. Oh, I just put a 1 in. It's imaginary. If there isn't something there, you assume it's a 1. All right, and then last but not least, what do I do to get y by itself here? This one's easier. What do I do to get y by itself here? Distribute the 3. So y minus 5 equals 3x. And then what do I do with the 5? Add 5, add 5. And you end up with y equals 3x plus 2. Very good. All right, is this parallel to either one?
Yes. Number 1 and 4.
I want to say 1 and 4, but there's a problem. The y can't be the same. So are those parallel? No. They are actually what? Coincident lines. They're actually right on top of each other. So these are not parallel. So the only lines that were parallel were 2 and 3. All right? That's a lot of work. That's why you're not going to have a ton of these problems, because it's a lot of work, because you have to figure out what all the slopes are for all of them, and then you've got to figure out the y-intercept. So there's a lot to do there, but once you are able to manipulate quickly into slope-intercept form, this is really good practice for that, because once you're able to do that, these go by really quickly. All right? So the only parallel lines are 2 and 3. All right, so before we go to our boards really quickly, we have parallel lines, but we also have perpendicular lines. What's a perpendicular line? Victoria?
2 lines that intersect.
Okay, they definitely intersect.
But they have a 90 degree
And they have a 90-degree angle. Very good. Thanks, Austin. Thanks, Brian. They have a very specifically, they intersect at 90-degree angles, which is why we put this little box here, all right? Because they are perpendicular lines, so they make a 90-degree angle. What's the slope of this red one? Negative 2 over 3. So the slope of this one is negative 2 over 3. What's the slope of this blue one? 3 over 2. Positive or negative? Do you notice anything about those?
They're upside down.
They're flipped, and one's negative, one is positive. So perpendicular lines have opposite reciprocal slopes. Let's break that down. Opposite means if one is negative, the other is positive. Reciprocal means flip the fraction. So that means if one is negative 2 over 3, the other slope would be 3 over 2. All right? So positive 3 over 2. Except if they are vertical or horizontal. Vertical and horizontal lines are always perpendicular. So y equals 3 and x equals 2, those would be perpendicular. All right? Y equals x equals, that means it's perpendicular. Because if it's just a y equals and it's just an x equals, that means one is vertical and one is horizontal. Okay, so which ones of these would be perpendicular? Which ones of these would be perpendicular?
The two red.
What's the slope of the red one? Right here. What's the slope of this one? 1/4. What's the slope of this red one? -4/1. Are those opposite reciprocals? Yes. So those are perpendicular to each other. Okay? And then what about the blue ones? There's no slope of the blue one. What's the slope of the horizontal line? 0. What's the slope of a vertical line? Undefined. Are these two lines perpendicular? Yes. If one is horizontal and one is vertical, they're perpendicular because one goes straight up and down and one goes straight across. All right? So this would make a right angle. Okay. At your boards, I would like you to, before you move, this is slope of line 1 is 5, slope of line 2 is -1/5. You're telling me if it's parallel, perpendicular, or neither. Parallel, perpendicular, or neither. Go ahead. Okay, so how can you tell, again, if they are perpendicular?
If they're like,
They're flopped and they're negative. So, Alfonso, opposites. So, like for number 1, what do you have to do first with this 5? Alfonso?
You gotta see both opposites and you gotta see if it's perpendicular.
Yeah, what should I do with the 5 first? Put it over 1. And then it's opposite and it's a reciprocal. Good. So you flip the fraction and change the sign. So be really careful because number 4, for example, is a neither. Number 4 is neither because it's flipped, but it's not. They're both positive, so it'd be neither. All right? Okay. So how do we then use that information to write equations of a line? So letter A says write an equation in slope-intercept form. So slope-intercept is which? All right, you do not need to memorize the equations, but you do need to know which is which, okay? So slope-intercept is y equals mx plus b, and I want to write an equation in that format of a line that goes through 4, 5, so that means it goes through this point, and it's parallel to this line. So it's parallel to y equals 5x plus 10. So it goes through that point and it's parallel to this. So if I know that it's parallel to this line, what do I know about it? That they're parallel lines, which means they have what? The same slope. So what's the slope of this one that I underlined? 5. Just 5, not the x. The x is part of the slope. So 5. So then what's the slope of the line I'm trying to figure out? Also 5. All right? If the slope of this one is 5, then the slope of this one is 5. So how do I put that into an equation now? I can't put it into this yet. I can't put it into y equals mx plus b yet because I don't have slope-intercept. What do I have? Point slope. So what's the point slope formula? All right, so I'm going to put it into that. So I've got y minus what? Minus 5.
equals 5, and then x minus 4.
Okay, so y minus 5 equals 5, x minus 4. Then all I need to do to get it into slope-intercept is get y by itself. So what do I do there?
Solve it.
Distribute the 5. So I go y minus 5 equals minus 20. Good, because I've got to do it to the x and the 4. And then the last thing I do is just add 5. Add 5. How come I add it here underneath the 20 and not to the 5x? Has to have a like term, so I have to add it to something that doesn't have an x. So all I have left on this side is y, and then what does this give me? 5x plus negative 15 or just minus 15. Either one of those is fine. Okay, and that's your answer. So there's my equation in slope-intercept form of a line that's parallel to this, has the same slope, and it goes through this point. Okay? There's a lot of work involved in that problem. There's a lot of work there. But it's all very doable. Okay, last one. What if I ask you for the same thing, except instead of parallel, I want it to be perpendicular? All right? So perpendicular to a line that goes through 3, 2. So I've got a point, and the point is 3, 2. And I need a slope. And I know it's perpendicular to this. So how am I going to figure out the slope then? Well, the slope of that line is what? 3. So what would the slope of a line that's perpendicular to that be? Negative 1 over 3. Why is it negative 1 over 3? You flip it and you do the opposite. So it's negative 1 over 3. So then what's my equation? Y minus 2 equals good. All right, great job. Okay, so Fatima, what do I have to do first again? I have to distribute. And again, we are not going to freak out just because it's a fraction. All right, so we've got y minus 2 equals negative 1/3 x. All right, and then this is a negative times a negative, so that's going to give me a positive. So I'm going to do 1/3 times 3. So I do 1/3 times 3 over 1. What's 1 times 3? 3 times 1. So that really just gives me 1. And then last thing, minus 2 becomes a plus 2 plus 2. So I end up with y equals 3. Perfect. Negative 1/3 x plus 3. So there's a lot of steps, but all the actual math should be relatively simple. All right, Gabe, did you have a question? Yes. Like this one? It's either way. The whole thing is negative. You can make either the 1 negative or the 3 negative. Can't be both, because if it were both, then it would be positive. Like if it were negative 1 over negative 3, what would happen with those negative signs? So I always make it the top one, but you can make it the bottom one if you want. All right, you only really need that when you're plotting it on a graph. All right, Geraldine? Okay, yeah. So it doesn't matter how you write it on paper. It really just matters when you graph it, which one you decide to make negative. And again, I don't care. I always do the top one. So I always say negative 1 over 3. Okay. Questions on how to do that? There's a lot to it, but you guys are very capable. Okay. I'm going to go back to it. I want you to do your exit ticket, but I want you to do it on your boards. So I want your exit ticket on your boards, which means don't erase anything because I need to check it all. Let me make this a little bit bigger, and then I'm going to label these for you. So this is 1. This is 2. This is 3.
Oh my gosh.
Guys, relax. Hang on. There's not 4 separate problems. You're just telling me which ones are parallel. So you would say like 1 and 3 or 2 and 4. Just give me one set of parallel lines. All right, so that's 1, 2, 3, 4. We'll make this one 5, 6, 7, and 8. Okay? And then down here, this one will be 9, 10, 11, and 12. Okay, so there's only 3 problems, but you're just matching up which ones are parallel and which ones are perpendicular. For 5A and B, you have to do those both all together.